Hello everyone and welcome to TLE Eliminators CP-31 Sheet Solutions. Today we'll be discussing the 1600 rated problem, maximum product strikes back. So let's open the sheet. It's the 17th problem. So we open up the problem and yeah, let's go ahead and read the question. Okay. We are given an array of n integers for which the following is true. -2 less than a of I less than equal to 2, right? So that means that the values can be -2, -1, 0, 1 and +2. We can remove any number, possibly 0 elements from the beginning of the array and any number, possibly 0 elements from the end of the array. You're allowed to delete the whole array. You need to answer the question, how many elements should be removed from the beginning of the array and how many should be removed from the end of the array, so that the result will be an array whose product is maximal. If there's more than one way to get an array with the maximum product, we can output any of them. Okay, so we need to give an L and R, or not exactly L and R, we need to give like a left deletion, R deletion, so that the product of the array is maximal and the products of an empty array should be assumed to be 1. Okay, so the products of an empty array should be assumed to be 1, and yeah, n goes up to 10 power 5. Each element has absolute value less than equal to 2, right? So let's go ahead and note that down. Time complexity expected should be big O of n or big O of n log n, right? Because n goes to 10 power 5. And yeah, let's get started. Let's get some ideas. So ideas, fine. So first thing we can notice is if we delete the whole array, okay, so observation 1, delete the whole array, our answer will be at least 1, right? Answer will become 1. So that's why we want to maximize the answer. The answer will be always greater than equal to 1, right? So if we want, we can just delete the whole array and get a good answer, right? So we should only consider looking for answers greater than 1, right? Answers greater than 1, those are the ones we need to find. In case they exist, then we need to take that as your LNR range, correct? So that means that we need to think about powers of 2, right? So our answer can be either 2, 4, 8, 16, right? Because it has some number of 2's in it. This also means that our chosen array should not contain zeros, and the product of the numbers should be positive, right? The product of the numbers in the chosen subarray, right? So basically we're choosing a subarray itself. The product of the numbers in the chosen subarray should be greater than 0, right? So there should not be negative also, right? Okay, so what do these few observations lead us? So this is observation 1, observation 2, observation 3. Okay, so let's say the input elements are something like 1, 1, 2, minus, so 1, 1, minus 2, minus 1, 2, 0, 1, 2, minus 2, 1, minus 1, 0, and let's say minus 1, minus 2, minus 1. Okay, something like this. This is our input. Fine. Yeah. Now we know that we don't need to take zeros, so we can make chunks, right? We can make chunks which exclude the zeros. Okay, which exclude the zeros. So for each number we start at some L value, we go up to an R such that the 0 is not included, right? The 0 should not be included. And similarly here, right, L to R, similarly here L to R. So we should never include zeros because obviously our minimum answer is to already 1 if we delete the whole array. So we never need to include a 0 in any answer. Fine. So we get these chunks and we need to process these chunks separately. Now what do we need to do for each chunk? Okay, what do we need to do for each chunk? What we can say is, okay, so what if we can just count the number of 2's in each chunk, right? So that's perfectly allowed since we can iterate the array once. So that's O of n itself. We can count the number of 2's, right? We can say that this chunk has number of 2's equal to 2. This chunk also has number of 2's equal to 2. This also has 2, right? Or maybe let's change this to -2 so we have some diversity. So the last element was also -2, right? Okay, so we can say that this chunk has number of 2's equal to 3, right? That's one thing we can see. Ideally, we want to find the chunk with the maximum number of 2's we can get, right? But also second condition is that it should be greater than 0, right? When we multiply it out. So here negative negative will make a positive. So this range is fine. This range we can take fully because it's greater than 0. This range also negative negative makes positive. So we can take the full range, right? Because it's greater than 0. Let this be -1 itself. Okay. So yeah. Now in this range, if you observe in this range, we have an issue, right? Let me just write it down neatly. Let me just write the range down neatly. So we have basically -1, -2, -1, -2, -2. Okay. Right. So in this range, if you observe, we are going to have a odd number of negative values. So our final value will also be negative, right? So that means we need to exclude some elements from the left. We can either move our L pointer or we can move our R pointer back, right? So let's try moving our L pointer first. Now this whole thing is positive, right? This whole thing is positive. It has 3 2's, right? Now we can keep the L pointer here itself and move the R pointer back. This whole thing is positive and it has 2 2's, right? So that's what in the whole product is negative. Then we'll have to try 2 strategies, right? Whole chunk product is negative. Then we'll have to try 2 strategies, right? 2 strategies. The first one, move left pointer until the product is positive, or move right pointer, move the right pointer until it is positive. Okay, until it is positive. And these are the only 2 strategies for when we have a negative product, right? So that's about it actually. Basically we have almost arrived at the solution. So the solution is just going to be first step. Okay, steps. 1, split into chunks, right? Split into chunks separated by zeros, right? Separated by zeros. Second step we can do is, if product is positive, just take max of count of 2's, right? Compare max count of 2's, right? Because that's what makes the number larger than 1. That's what makes the answer larger than 1. Update the best answer if needed. Okay, update best L, best R if needed. Okay. Now if the product is negative, we have to try 2 cases. So the first case is increase L pointer till it's positive, and here it will be decrease R pointer till it's positive. Okay, decrease R pointer till positive, right? And we should try both the strategies. In whichever strategies, we again compare the max 2 count and update, right? Compare the 2 count, we'll call it TC, with best count, right? Best 2 count. Update best L and best R if needed, right? Update best L, which means the best L elements to be deleted from the left and best R elements to be deleted from the right. Okay, so that's about it. And the whole time complexity for this, to do this is also big O of n, since we're just going through a chunk once. Again, we're going through the chunk again maybe, but that's also another big O of n. Big O of 2 times n is the same as big O of n itself. So we can write the overall time complexity as big O of n, right? Obviously we need to store these values in memory. So the memory complexity will also be big O of n, right? And that's the solution to the problem. Pretty straightforward. Although the implementation can get tricky, right? Implementation, be careful with it. Do implement this afterwards yourself also, while like just to absolve, because me explaining it to you and the idea is very simple, right? But the implementation off by 1 errors happen a lot in this question, in my opinion. So do try that. Okay, so implementation, be careful. Very easy to make off by 1 errors while making chunks or while making L pointer, R pointer. In my opinion, it's best if you make like a function for each chunk and then you generalize it that way. But yeah, even I have not made a function, so I just used the equations and made sure that, you know, every bound was correct. Okay, so let's now go through the code. Time and memory complexity are obviously big O of n, right? Okay, so the code is a bit long and a bit, maybe it's messy because this is the best solution which I wrote. So you take in n and the values of the array. We have a best, so it's going to be the best 2 count, best left deletion, best right deletion, right? So whenever the best gets updated, best L and best R will be also updated. Our final output will be best L and best R, right? Now for left pointer goes from 0 to n, right? If the current element is 0, then we can just do L++ and continue because we want chunks of non-zero. Now we're going to find the first point R such that it is so we need the longest R, right? Then zeros will start or the array will end. We need to move the R pointer as much as possible. So while R+1 is less than n and the next element is not 0, we increase R, and if the absolute value is 2, we're going to count the 2's also, so the 2 count will increase. If it's negative, we can multiply the negative by -1, right? So we're keeping track of whether the whole product is negative or positive. If this negative equals 1 at the end, so that means the whole product is positive. If the 2 count is better than the best so far, update best L, best R, and best 2 count. Increase L equals R+1 and continue, right? So this is for the positive case, right? So this was step 1 is done, step 2 is done. Now we're going to do step 3, right? Step 3. So now if the negative is set, right? So obviously negative must be -1 right now. First we'll move the left pointer. So we're going to make a temporary 2 count and a temporary left pointer. We increase the temporary left pointer. And also we need to make sure that 2 count gets decreased, right? So when we move the left pointer, the 2 count gets decreased. If this is better than the best one, then we update accordingly. Be careful with the pointers, okay? So it should be NL+1. So if we're removing the first negative, then it should be NL+1, right? And we update the 2 count and everything. Now right pointer also, we try to decrease the right pointer and find left to new right pointer. We again have a new 2 count. So we count that. Go through the loop ones, go through the code ones carefully. Just make sure that your bounds are correct and you have checked them, okay? Because it can be implementation hazard over here. Okay. Again, if the new 2 count is better than the best we have seen, best L gets updated, best R gets updated, right? So whenever we find the first negative, we should delete up to that. So we go R+1, right? So the R-1. That's why this is the equation. And we update the 2 count. And then we can do L equals R+1 and go to the next chunk, right? So finally, when this whole thing is done, we can output the best L and best R values. Right, so that's it. The idea is pretty straightforward. The implementation can get tricky. So do try solving it. Yeah, that's about it. Thank you for watching. I guess this brings us to the end of this session, right? Thank you for watching and see you in the next solution. Bye bye.